Now I'm going to discuss an example about how to apply Coulomb's law. And the first example that we will start with is the calculation of the force between two two-point charges. Now, we assume that we have, these are our coordinates, and we have two charges. This is positive, and the other charge here is negative. This is Q1, and this is here Q2. This is the distance between the two charges is R. Now, we are given that Q1 is equal to 2 microcoulombs and Q2 is equal to minus 4 microcoulombs, and the distance is equal 0.1 meters. The R, the distance between the charges, is equal to 0.1 meter. Now, what I need to find is, I want to find what is the magnitude of the force F12, which is the same as F21. What is this? And also, I want to find an expression for the vector F12, which is the force vector by charge 1 on charge 2. Now, this is the simplest application of Coulomb's law. Now, to start with, when you want to solve a numeric problem about Coulomb's law, then what we do is you first show the forces that you want to calculate graphically using your knowledge about the forces, the fact that the similar charges repel each other and opposite charges attract each other. So I have here a positive charge and a negative charge, so the force between them is an attractive force. So, for example, this is F12. This is the force by charge 1 on charge 2. And this is F21. This is the force by charge 2 on charge 1. Okay? So this is the first thing that you have to do. Now, we move to calculate the quantities that we want to calculate. The first thing that we need to calculate is, this is A, is the magnitude of F12, which is equal to the magnitude of F21, of course. Now, in this case, you apply Coulomb's law and say that, you use the formula for the magnitude and say that, well, F12 in this case is K Q1 Q2 over R squared. Note that you can either substitute modulus Q1, modulus Q2, or just the modulus of the product. At the end, this quantity here should be positive. Okay? So this is your formula, and after that, what remains is to just enumerate this formula and make your calculations. And this is easy in this case. So F12 in this case is just substitute it. K is equal 9 times 10 to the power 9. And these two quantities are just, I have minus 2 and minus 4. So it is 2 times minus 4, this absolute value, and times 10 to the power minus 12, because I have micro 10 to minus 10 to minus 6. And then in the numerator, I have, which is 0.1 meter square, which is 1 times 10 to the power minus 1 square. And if you do your calculations, then you get this equal to 7.2 newtons. So this is the magnitude of this force. Now, this is the easy and straightforward part of the solution. Now, when it comes to B, I want to find the vector F12. That is, what is the force by charge 1 on charge 2 in vector form. Well, I know what's the magnitude, so I know what's the magnitude of this force, and I am given, of course, theta here. Okay, I mean, in the problem, theta is also given, and this theta is equal 37 degrees. I'm assuming that this is also given. Now, with these with this data, with this information, you want to express f12 as a vector. Now, how you can express it? Now, we know the magnitude of the vector. To express a quantity as a vector, there are two ways. Either you give what we call the polar form. You give the vector as a magnitude and as an angle with the positive x-axis, or this is one thing. The other thing, the other way is to express the vector in terms of unit vectors. So let's do it both ways and see. Now, according to this figure here, let me just sketch it again here. So this is Q2, this is Q1, and I'm given that this is 37 degrees. Okay, then in this case, I know this is f12. Now, this f12 is a vector, and this vector has a magnitude 7.2 newtons, and I want to express it as a magnitude and an angle. And for this angle usually is given with the positive x-axis. So if you draw the positive x-axis at the location where the vector acts, then I have to report the vector as the magnitude plus the angle. So f12 in this case is equal to 7.2 newtons, and phi, which is the angle that it makes. What is this angle? Actually, if this is 37, this is 37, so this whole thing here is 180 plus 37, which will be phi is equal 180 plus 37, and this will be 217 degrees. Okay, so this is one way of reporting. Now, the other way of finding the force is to write it as in terms of the unit vectors I hat and j hat. So as you can see here, I hat and j hat are defined as usual here. Now, I express this vector f12 in terms of the two components, which is f12x and f12y. These are two component vectors. So f12 is actually f12 modulus cosine 37 degrees, and this, I put a minus sign here along I hat because it is pointing in the along the negative I hat direction, and minus f12 sine 37 degree, and it is pointing along the negative j direction. Now, what remains is to substitute for f12 7.2. You substitute for cosine 37 degrees 0.8, and for sine 37 degrees you substitute 0.6, and the result in this case will be minus 5.76 I hat minus 4.32 j hat. So this is f12. Now, if somebody asks you, okay, then what is f21? Well, f21 in this case is what? It is just minus f12. And therefore, multiply this vector by minus 1, so it becomes 5.76 I hat plus 4.32 j hat. Let's check that this goes with our intuition. Where is the vector f21 in this case? It is this. And indeed, this is a vector which if you draw, is in the second quadrant. So both of its components are positive, as you can see. This is f21x, this is f2y, and so you get the expression that you expect.